So one more thing I'd like to add to our game is the ability to report and track statistics, such as how many times enemies have been slain inside of the game. So we would need one node to report that data, and then another object, possibly the combat state resource, to receive that data and track it, and then maybe connect to that data through, let's say, a UI component in order to show that on the screen. So if we go to the invader scene, we can see our health component. On player, the health component is also here. And in order to know what type of enemy died, we'd probably need a reference to the root node of our character scenes. So in this case, it's the invader enemy. In the player scene, it would be the player character script. The health component already has a reference to the combat state, so that's easy enough. Inside of the health script, if we open that up, so on the health component, we could report that the character died and is alive, like the combat state health changed was reported. But that could be possibly problematic. If you have an enemy that has, let's say, multiple health components for different parts of the enemy, like a boss fight or something like that, then the enemy isn't technically completely dead until all of the health components have hit 0. So therefore, we would probably want to put the code in the invader script or the root object in case we need to customize that. So you could like extend and then override it or something. So if we look at the invader script, we have this platformer character 2D. So we probably want to put in a reference to the health component here at export var health of type health. So every platformer character presumably is going to have a health component. So when the health component is set, if one exists, then we'll do set value, the setter, and we'll connect to its signal for when the character is no longer alive. So if is valid instance is instance valid. The health, then we'll disconnect from the signal. Health dot is alive changed dot disconnect on is alive changed, and then health equals value. Remember, that's the health component, not the value of the health, the current health. Then we just need this copy pasted again down there, but now we connect. And we need is alive changed to have a callback down here at the bottom. So function underscore on is alive changed. This is going to get the p value, which is the Boolean. So is it true or false that the character is alive? Or maybe P is alive would be a little bit more appropriate. So if P is alive, and we'll put a not before that because we're talking about the death state, then we're going to report on the combat state that this character has died. So I guess we'll need the combat state too. So at export var combat state, and this is of type combat state. So down here at the bottom, combat state dot report death, and that'll be self. And I'll quick load this in the inspector. So quick load combat state, go to the player scene and make sure that's set there too. Quick load. Okay, and now basically through the health component, we know if the character has died or not, and then we report the character being dead over here. So in the case of a character that had multiple health components, we would probably check on is alive changed that all of the health components for that character have reached 0 health before we report it as being dead on the combat state, since you'd have to defeat all the parts of a boss before you can report it as being defeated. So you can override or create a separate script or anything you need for that, but basically the health component needs to be untouched, since this is just managing one health component, but not necessarily all of the health for a character. So if we go to the combat state, we have the report death. So for the report death, we want to check what kind of node died. If it's one of the valid types, then we report it. Otherwise, we'll probably give a warning that it's not handled properly. So if p node 2d, and you know what, I'm going to actually just kind of rename this to be p node, and I'll actually just make it a node type. Theoretically, it doesn't have to really be a 2D node. Maybe a script actually is separate from the character body, and we want to allow for that too. So if p node is a, let's say a enemy character 2D, then enemies died plus equals 1. And we could have if p node is player, then player deaths plus equals 1. And maybe for each of these, we do return. And maybe we just want to make sure that at least one of these types is valid. So we could say var handled equals false. And whenever these run, we'll say handled equals true, handled equals true. But if not handled, then we want to push a warning. Try to report death on node. I'll do %string replaced by the node name. But no matching type was found. Okay, and then to replace that %s, we can do a % and then p node dot name. So this just takes this string value and puts it into here. So for these, I could just use the class of the root node. So if I extend enemy character 2D from platformer character 2D, then that would work here, kind of implied. Or the player class already exists, but I think that's a little less flexible because the nature of labeling it an enemy by using the class name like that means that any child classes have to inherit everything from the parent, including functions, how it operates by default, and properties, and so on and so forth. So really, I just kind of want to classify different objects in the game. So I might create so one way would be to create an enum variable, which has a bunch of types, though that has to be hard-coded. And instead what we could do if we want to be extra flexible would be to create a resource type. We could call it object classification, and then we assign one or more to any root node of a player, an object, a scene, and then just read that from here to see if the classification exists in the array of classifications. And if so, then we can report it as an enemy died or a player died. There might be some situation where maybe a object is both an enemy and a player, or a inanimate object, but also a player. And we might want to include both of those in the handling of that. So let's see, to do that, we could go to the data folder. I'll right click, create a new script. This will inherit from resource. I'll call it object classification .gd. We'll open this up, give it the class name object classification. This probably doesn't really need anything else. So I'll create a folder for object classifications. So object classifications, and I'll move object classification.gd into that. And then inside of here, I'll right click, create a new resource of type object classification. And then we can just give it the name of the classification. So I might have one for, let's say, object type player, and hit save, and then do that for any other type we need. So I'm actually going to rename the folder to be object types, object underscore types, and we'll rename the class to be object types. The class name can be, let's call it game object types, and hit save. I'll rename the script again, game object types, and the folder name game object types. So why am I calling it game object types? Well, there is a class object that is the root of everything inside of Godot. Every node, every resource is a object technically. So I want to be specific that we're talking about inside of the game, the gameplay objects, the ones you see on the screen, is what we're talking about here. So that would probably mean that we rename the object type player to be game object player. Let's create some more game object types. So if we look for game object types, we just create one of these for anything we need. So game object enemy, and then I'll right click, create a new resource, game object types. And then we'll say maybe game object NPC. Let's create one for inanimate objects. So maybe just game object inanimate, because I think that would be a separate category from enemy, NPC, and player. It's possible that could be a better name for that. Okay, so for each of these, we can put these into the combat state. So now in the combat state, our state needs to know about which type will get assigned to which variable here. So when an enemy died, which type of game object do we use to report that an enemy died, which of course would be the game object enemy. Did I actually create that? Yeah, I did. So we need a few export variables in the combat state here. Or maybe rather than importing them straight in the combat state, what we'll do is just create a global object. So a global object to hold all of the types and kind of universalize them in the project. And this will be game object types.tscn. I'll create that in the folder. Let's open that up. We'll assign a script to it. So this will just be game object types.tscn. So the script for this will be global game object types.gd. I'll create that. And then we can add our export variables here to assign each type to a property name. So at export var enemy will be, of course, game object types. And then we do that for each one we need. So at export var player game object types, at export var npc game object types, at export var inanimate, which would be game object types. Okay, and now I'll just assign each of these in the inspector. So inanimate, NPC, player. Okay, so let's make that a global. So let's add the path for data, game object types. And I'll make this list view. We want the scene, game object types.cscn. Add that. Must not collide with an existing class name. Right. So maybe I rename that to be global object types. I'll go to project settings, and we'll add that in again, global object types. Add that. Okay, so now in the combat state, we don't need to specifically reference each of these individually because we can just use the global types now. But first, let's make sure that our object stats has a list of game object types that are assigned to it. So if we open up the script here for editing, so I just click a couple times and we get to character stats, but really I want to look at object stats. So this will be at export var types, which is going to be an array of game object type. Yeah, and that should really be a game object type, not types. So if I open up the script for game object types, let's make that a type. And then I'll rename the script as well. That probably does mean, and the global game object types, that I need to change the class name as well. So just to update that. Because if we're talking types, we're talking plural. So it really makes sense to make the base class name singular. Just tab things over a bit. And yep, that looks good. Okay, so our object stats has an array of game object type called types. So if we open up the invader and we look at the invader stats, we'll have this null array here. Let's reset that to a size 0 array. And I can add in as many types as I want here. So at this point, it becomes a little more flexible than an enum, because first off, you can create a new type in the file system just by creating that new resource. And secondly, you can assign as many as you want to this invader stats object. So it is just an enemy. So I will, for some reason, it still says game object type. So let me check object stats. Maybe I need to reset, add one in, quick load. Cannot get class game object types. Okay, I think the project needs a reload. So now we have game object type here. So I just need to drag and drop whichever ones I want to assign to invader. Invader is a type of enemy. And now if we go to the combat state, we can get the stats types. So if our types is an array of game object type, which is going to be equal to pnode.stats.types. All right. So this basically means that on any root node, we do need to implement the stats.type, but since basically any root object is going to have object stats, it should have this variable. So we do expect that to show up. So stats.types. And so we can check for the types that we need to. And if that type exists in the array, then we increment enemies died or player deaths, so on and so forth. So we can just be like, if types.has, and then we do global object types dot enemy, then we'll do enemies died +1 and handled equals true. And we can just do that for each type we want. So if types dot has global object types dot player, then player death +1, and handled equals true. So we cut this bit down there. And so now we can basically just add in new types, reference them in the global object types, and we'll be able to handle them inside of report death. We don't need to worry about making the player character 2D script of a enemy character 2D script. So we don't need to like force inheritance. We can just have this separate type resource defined in order to set things. So enum would also probably work fine. But doing it this way does mean that you can create new types without messing with the code, where enum you have to hard code those in. Okay, and now we just need to make sure that each platformer character 2D is going to reference the health. We get this combat state report death going. So our player needs to assign the health component, and our invader already has it. So if we go to the combat state, we should be able to set a couple breakpoints here and see if we can get that to trigger. Oh, but we are going to need to set the weapon stats to a value where we can actually damage the player. So maybe the invader hits for 10 again, and the weapon stat basic goes back up to 25 damage, so that'll make combat actually flow. And we go to hit play. So let's hit the enemy 4 times here and see if we get the debugger to trigger. So we had one error. Tried to report death on node invader, but no matching type was found. Okay, I'm going to put a check on platformer character 2D. So on ready, function underscore ready, I'm going to check that stats.types is not empty. So if stats.types is empty, push warning, no game object type assigned to %s stats. And that's going to be the name of this node. Okay, let's see. If I hit play, do we get any debugger messages? Yeah, we do. Okay, so we can see that all of the player, the invaders, they don't have any object types assigned. Which is weird because clearly it is there in this array. Okay, so I can't exactly say at the moment why this is happening, but the fix, or at least a fix for why the types array ends up empty at load, is that at load there's 2 assignments to the types array. So one is going to be the values we actually set in the inspector, and the other is where you make the array empty. I think usually it would flow in reverse, actually, where usually it sets the empty array and then it gets the export values and assigns those. But what was happening right now is that it assigns the array that has 1 into there, and then it assigns the one that has 0. So when the game actually loads and everything's ready, that it would have 0. So as a setter function, you can just say that if the value is empty, we ignore it and return, so that only the setter that has an actual value in there is going to matter. I'm not sure why that is. It could have something to do with the init function and not being local to the scene, but that at least fixes it for now. So as you can see, there's no debugger messages. If I shoot a guy a few times, we can see that the enemy type is actually processed here. If we expand types, we can see the enemy type is there. So at least for now, that should work. Just as a safeguard, making sure that we actually only grab the array that has the data in it, because that's all we really care about. So we could also test this with the player. If I hit play and go take damage a bunch of times, we should be able to count how many times the player died. So we've got the player deaths +1, so 1 enemy died, 1 player died. Okay, so we set up object types in the game, and now we have our simple counter here. So when player deaths changes or enemies dies changes, we can emit a signal on those. So I'll say signal player deaths changed, and we'll say count integer, and we'll have signal enemies died changed, which will be count integer. So to emit those signals on these properties being changed, I'll just say that when the property changes, that the signal gets emitted. So set value, and we'll say if player deaths equals value, we'll just return. Otherwise, player deaths equals value. Okay, so 2 equal signs to do a Boolean check, 1 to assign. And then, so if we assigned a new value, then we want to emit that value changed. So player deaths changed dot emit player deaths, and then we have basically the exact same thing for the other property. So just copy paste that there, and we replace player deaths with enemy died, just like that. So when the number of enemies that have died in the game changes, we emit that signal. Okay, with those signals there, it's now very easy to connect it to UI. Okay, so now in gameplay, our UI is going to need some kind of game stats control. So I'll add a new scene, user interface. I'll rename this to be game stats. Let's change the type to be a panel, so that it kind of has like a background theme there a little bit. And so I'll give this a script with the add script button. We'll save it under UI. So game stats.gd. It doesn't necessarily have to extend panel. It could just be control. Unless you want access to the panel, then you can leave it as extends panel. And let's see, we don't necessarily have to give it a class name because we're only going to really use one in our game. And so this is going to need a @export var combat stats reference or combat state. Okay, and save that. Okay, so we need to save this TSCN and UI. So save. Okay, we need to get the combat state, so quick load that on the inspector. Okay, and that's going to give us access to player deaths and enemies' deaths. So we need labels now in order to display that information. So right click add label, and this will be, first one will be enemies slain label. Okay, and we'll duplicate that, and then this will be the player deaths label. So in the game stat script, reference both of those. @export var enemies slain label, which is of type label, and then @export var player deaths label of type label. Save that, assign the labels. Okay, and now we want to connect to the signals in the combat state. So just like I usually do, first we'll check if it's valid. So if is instance valid combat state, then we're going to disconnect from any existing signals for the old one. So combat state dot enemies died changed dot disconnect on enemies died changed, and then combat state dot player deaths changed dot disconnect on player deaths changed. Okay, and assign the new value to the combat state. So combat state equals value. Copy this below. Do connect instead of disconnect. And now we need to, well, let's stop the game first. And now we need to create these callback functions. So function on enemies died changed, we have the p new count, and then we put the text on the label to reflect that. So enemies slain label dot text is going to be equal to enemies slain colon %s, or %d actually, because we're going to do a decimal value, and then we do %p new count. Should specify up here that that's expecting an integer. Okay, and now we do basically the same thing again. So I'll copy and paste that down below, get the different function name on player deaths changed. We use the player deaths label, and we change the text to say, let's say deaths or player deaths to be more specific. So that's still using p new count, the parameter. And on load, we do want to get those values as well. So we'll say function underscore ready. And you know what? We could use a function to reuse the code too. So let's do function set enemy slain label with a p new count integer. And then this comes up there. And then we call this function down here, p new count. And on ready, we'll basically do the same thing. We'll just do calling this, and we're getting the value from the combat state. So combat state dot enemies died. And then we'll have another function. So function set player deaths label with p new count. type integer. We get this bit to there, then we'll call that down there. So we pass in the p new count. Okay, so on load, we also set the player deaths label to the combat state dot player deaths. Let's try hitting play and see if the text loads like it should. Okay, we can also give these text labels some default text. So I'll say like unset and unset. We do need to give it kind of like a hierarchy here. So I'll right click add a child node, and we want a container, or specifically a VBox container. Move the labels inside of here, and then they'll be stacked on top of each other. We want to put the game stats into the UI. So game stats.tscn, drag and drop that in UI. And now it should be set there in the top left. Let's hit play and see where we're at. Okay, I can see that the text is being set, but it is really hard to read, and it's not following the screen. So if we want to make the text always stick with the same screen position, we should give it a canvas layer node. So right click, add child node, canvas layer, put that down there, and then move the UI game stats into that. If we hit play, then, well, let me see if I can move out of the way enough. So then you can see up there we have the text showing. Now that's also going to affect the size of things. So the canvas layer is no longer going to scale with the game world. So we need to be aware of that. I'm going to take the font size and triple it for the UI theme to 48. In game stats, for the gameplay, for the game stats, let's make sure that this is big enough. So I'll say layout, anchors, top left. I'll hide the game world temporarily so we can see this. And so anchors preset, I'm going to change that to full rect. Okay, let's work on positioning and sizing the game stats. So inside of the game stats scene, okay, I'm going to make sure that everything is top left, I guess, top left. And then the game stats, I'll give it the container size. So expand and expand to its children sizes, and then the VBox container. I think we also need to expand it. Okay, so if we do that and we go back to the play the main game, we can see enemy slain and player deaths show up there. We might need to give it a little bit of a margin container. So I'll right click, add a margin container in. The VBox becomes the child of that, and then the margin container. We can do theme overrides. I'll give a 10 pixel margin on every side. Let's hit play. Okay, we can kind of see it spaced out a bit more there, maybe 20 pixels on the left even. And let's show the world again. Hit play. Okay, we can see our text up there. So we're going to need to make sure that that is visible, and that's going to require changing the... So I'll embed a new theme into these, which is going to change one thing, which is going to be the font color on the labels. So I'll do add label and font color. And so if we go over here to the inspector, we can choose the font color we want, and I'm just going to make that kind of like a red. So let's hit play, and we should be able to see our text up there in the top left pretty visibly. But you know what? I really need the panel to show as well. So in the game stats, let's give it a size and position, like 300 by 300 or 300 by 200. Hit play and see how that looks. Okay, so we got a panel kind of there in the top left. If we go to gameplay, we can position it with W and then move it a little bit away from the top left-hand corner, a little bit more to the right. Okay, so we can see it now. Let's test it by shooting a few guys. Okay, so the enemy slain seems to be working. Let's make sure player deaths is working up there. Okay, yep, there. So the counters are working. The data is being received, but we can see that the location where the hit damage is showing now no longer really makes sense because the canvas layer is different now. So our combat text system was putting it on the UI parent. If we open this up, combat text system, I might just change this to be parent, and this can be any node 2D. And what we'll do is we'll actually make it a child of the world, I think. So we can say parent.add child text to instance, and the parent is just going to be the world. So it'll move with the game world instead of moving with the UI. So if we hit play and we get hit for damage, okay, we can see that now that's working again. We can shoot, deal damage to these guys. That's all good. But perhaps we need a separate theme for the text template now. So I'm going to open up the text template. and I will give it a label settings. So new label settings. So this is kind of like custom for this object specifically. I'll quick load the font, M5X5, and font size 16. We'll just try that, sure. Okay, so let's shoot a few times. Okay, and now it's pretty much back to normal. We got our text working. We have our enemy slain counter and player deaths counter, and we could add anything else we needed up there. Stuff like basically tracking how much gold you have on the player would be mostly the same way. Whenever the gold changes, we just update it in the UI, possibly through a shared resource. And that's pretty much going to be it for tracking data statistics in the game. I think this part ended up being a little bit more complicated than I had actually originally anticipated, but hopefully you guys were able to follow everything. And I'll see all of you in the next part.